Hi everyone, in this video we look at two trigonometric ratios that are a little bit more involved or might require a couple of tricks. And this is based on student requests because some students asked me to post more videos and more video examples. So the first thing that we're going to do, like any other identity, is we're going to break up the equation into the left side and the right side. The left side is sine squared theta minus cos squared theta minus tan squared theta. The right side is all in terms of sine theta. So the right side is 2 sine squared theta minus 2 sine to the power of 4 theta minus 1, all divided by 1 minus sine squared theta. So the right side is pretty complicated. So let's just see if we can try to make the left side into something a little bit simpler. So the first thing to note is that the degree of this term is 4, and I only have terms of degree 2 on the left side. So I've got to try to figure out a way to simplify the right side and reduce the degree of this term. Or I could also try to, combine some terms on the left side and rewrite the left side as well. Would also work. So the first thing that I'm going to do is let's try to reduce the degree here. So one thing to note is that this term 2 sine squared theta minus 2 sine to the power of 4 theta is these two terms have a common factor of 2 sine squared theta. So let's go ahead and we'll common factor that out. So I have 2 sine squared theta times 1 minus sine squared theta minus 1, all divided by 1 minus sine squared theta. But one thing to note is that in the denominator, 1 minus sine squared theta, well, that's just equal to cos squared theta, right? So let's just write that as cos squared theta. Why not? And the trick with identities is to just, it's kind of like solving a puzzle. You just kind of have to think your way through it and say to yourself, like, how can I make the left side and the right side be equivalent to one another without violating any rules of algebra? So in the numerator, I also have another 1 minus sine squared theta, and that's just equivalent to cos squared theta. So I have 2 sine squared theta times cos squared theta minus 1, all divided by cos squared theta. So now I guess the question is there a way that I can make the, now that I've simplified this a little bit, is there a way that I can make the left side look like this? Now that I've reduced the degree of this term here. And so let's try now to work with the left side a little bit. Well, okay, so somehow I need a product such that I've got 2 sine squared theta cos squared theta somehow. And one of the ways I could do that is notice that I can rewrite cos squared theta in terms of sine squared theta. So I could rewrite cos squared theta as 1 minus sine squared theta. My right side is now written all in terms of sine theta and cos theta. So let's just rewrite tan squared theta as sine squared theta over cos squared theta. And let's see if this helps. Well, now I have that my left side is equal to well, here I've got negative 1 minus 2 sine squared theta when I distribute this negative. Oh, sorry, never mind. I would have 2 sine squared theta minus 1. Pardon me. I can't do basic distributive property. And then, so that's just from distributing the negative into this, into these brackets here. And then I would have minus sine squared theta over cos squared theta. So this looks pretty similar. And let me rewrite this just so that my fraction, you know what, I'm just going to leave it like that. Okay. So, this looks pretty similar, but notice that everything here is written with a common denominator. So one of the things I can do is I can just divide on the right side. I can divide each of these terms individually by cos squared theta. So if I do that, I get 2 sine squared theta, cos squared theta. Sorry, not cos squared theta. I would get 2 sine squared theta. These cos squared thetas divide out, minus 1 over cos squared theta. So now I've got to show, I can show that the left side is equal to the right side. And let's see here. I have 2 sine squared theta minus 1 minus sine squared theta over cos squared theta. And I'm tasked with showing that minus 1 minus sine squared theta is equal to 1 over cos squared theta. And we can do that by... actually, you know what? Maybe it's a little bit simpler. Maybe it's a little bit simpler just to rewrite the left side all over one denominator. Let's do that instead. So we could have done this, but my bad, guys. It's definitely a little bit easier to just rewrite the left side over a single denominator. So here I can find a common denominator. I can multiply 2 sine squared theta minus 1 by cos squared theta. And I get 2 sine squared theta cos squared theta minus cos squared theta minus sine squared theta, all divided by cos squared theta. And what we've done here is we just found a common denominator. All that I did was I multiplied 2 sine squared theta minus 1 by cos squared theta over cos squared theta. So that's why, and if you actually divided these two terms by cos squared theta, you'd get this term. So now, notice that minus cos squared theta minus sine squared theta, well, that's the same thing as minus... let's just rewrite this. We get 2 sine squared theta cos squared theta minus bracket cos squared theta plus sine squared theta, all divided by cos squared theta. And I know that cos squared theta plus sine squared theta is just 1. So I have 2 sine squared theta cos squared theta minus 1 divided by cos squared theta. And thus the left side, so notice that the left side and the right side are equivalent now. So therefore the left side is equal to the right side. So that identity is definitely a little bit trickier. It takes some, fumbling with until you finally get it. There's definitely a few ways to do this identity. But like I said, when you're writing a test or you're doing an assignment, you might not see the easiest way to do it right away. And then you can just go back and, like if you've really messed up and you got an expression that looks really, really ugly and you're not sure what to do with it, you could always erase your work and start over in case you've made a mistake, or you could try to find the mistake in your work. But that's definitely a little bit more time consuming. Definitely what I like to do is I like to just go back a couple steps and think to myself like, okay, if there's a simple way to rewrite the left side, then there has to be or if the left side is written in a simple way, then there has to be a simple way to rewrite the right side as well. Or there has to be a way to simplify the right side. So in the next identity, we have cos to the power of 4x minus sine to the power of 4x is equal to cos to the power of 2x minus sine squared x. So here I have an expression that is of a higher degree on the left side than on the right side. So first off, I have to try to figure out a way to simplify and reduce the degree of the polynomial on the left side. So best way to do that is to try to factor, because there's nothing I can divide out here. So let's try to factor. Now recall the difference of squares formula. And if you have a squared minus b squared, well, that's equal to a plus b times a minus b. And thus, I can factor the left side since it's a difference of squares. So first off, let's write out left side is equal to cos to the power of 4x minus sine to the power of 4x. And the right side is equal to cos squared x minus sine squared x. Let me just move this over a little bit. On the left side, we have that this factors, because it's a difference of squares, this factors to cos squared x plus sine squared x times cos squared x minus sine squared x. Now, cos squared x plus sine squared x is just 1. So we have 1 times cos squared x minus sine squared x, which is cos squared x minus sine squared x. And thus the left side is equal to the right side. So therefore the left side is equal to the right side. And we have proven this identity. So as you can see, this is one trick to reducing the degree is to try to factor.